Hello and welcome to another episode of RadioPublic, where we talk about great books with smart people. Today, as my guest, I have a mentor, a senior to me, and one of the people that I really look up to. His name is Merl Chandana. So, Merl is a researcher of data, algorithms, and policy team at LIRNEasia. And I met him at the Gavel Club of University of Morto. Welcome to my show, Merl. Really honored to have you.
I think the honor is all mine, and I'm very glad to be on the show. And I've listened to several of your episodes, and it's a really interesting take on a podcast that you are doing. So happy to be here and looking forward to a wonderful conversation.
Yes, thank you very much. And so, just like in every other episode, the way I usually approach it, I get a recommendation from a book. I get a recommendation for a book from my guest. So, I have seen, Merl, you posting a lot of book reviews and abstracts and summaries about books on social media. And that is honestly where I got the recommendation for my very first non-fiction book as well. And yes, so this time Merl, I wanted to talk about algorithms to live by. And yes, why did you want to choose this particular book?
So as the listeners might have heard from your introduction about me, I work in the data, algorithms and policy team at LIRNEasia, which means we are dealing with issues at the intersection of data science and policy. And we try to bring solutions to social, developmental, and other non-technical problem, I would say, from a data science perspective. And this requires me to think about algorithms beyond a technical capacity. It's not your mathematical theorems and proofs, but more about how the algorithms work, how and where to apply these things. And sometimes getting the right answer is not enough. You need to know why these algorithms work and why it didn't work. So that's where I'm coming from and the reason why I wanted to read this book. And so the fundamental premise, if I am to get into that, is the problems we face have a lot in common with the problems that the computers solve. So be it be sorting a range of numbers, or maybe it's about finding the perfect fit from a wide range of options. So for all of this, we use algorithms. So how do we apply algorithms in real life is the idea in the book.
Yeah, for a amateur listener, we would say, we will just go ahead and tell everybody what actually is an algorithm. So, according to the definition, algorithm is something like a set of instructions, like clearly defined set of instructions to be followed step by step to find a solution to a particular problem. So, algorithms is like, it's a fancy name, I would say. Algorithms is like, it's a fancy name, but it's everywhere, right?
Yeah, when you say algorithms, people think of nerds and robots and all sorts of things. But algorithm simply is a sequence of steps to solve problems, a sequence of well-defined steps, like you said, aimed at solving a problem. It's actually nothing more than that. So it can get complex depending on what the algorithm is, but the idea behind is like really, really simple.
Yes. So the whole beauty of this thing, of this particular thesis of this book, is that we ourselves, maybe we already do, we already apply certain kinds of algorithms to solve different problems that we face in the day-to-day life. And there are even better ways to do that if you are interested in these algorithms that are specifically used by computer scientists in their problem solving to your life. So shall we go ahead and tell like one or two examples where we maybe not knowingly apply algorithms in our lives?
One fun example would be, say, you are in your first year in the university and you want to find a girlfriend. I mean, there is also a saying that there's no thing as a girlfriend in the university. It's just an illusion. But but let's assume there are girls. But you might go about in like a million different ways. You might say yes and propose to the first girl you meet, or you will talk to as many girls as possible, and during your last semester you might propose to someone, or you will curate a list of all the girls in the university and rank them by the order of preference and see what characteristics they have, and you'll choose the most person with the most desirable characteristics. There are all sorts of ways to go about. So I mean,
some ways could be effective, could be creepy as well. Yes.
Could be effective, could be creepy. So that's the beauty of algorithms. I mean, algorithms have trade-offs. I mean, depending on what you need, you'll have to choose the right one. So that's the fundamental to solving problems using algorithms. So that's something else. Yeah.
So Algorithms to Live By, written by Brian Christian and Tom Griffiths, is all about how you can apply certain algorithms that are used by computer scientists to your life. So for me, like almost all the chapters in this book were super insightful in the sense that I hadn't really looked at these algorithms in that sense. For the most basic example would be sorting. So sorting, say, an array of numbers, it's something that we learn at our algorithm classes at the, say, on the very first day. So it's the small, like it's a very basic algorithm that we come across. But then applying that particular algorithm to the life, say you are arranging your bookshelf or you are sorting your emails, that particular aspect of it, I hadn't really looked at. So that was really insightful.
I think like one of the reasons this tends to happen is because we think our problems or human problems are uniquely human, and there would be nothing computers can say about human problems. But what our authors argue is that this is not really true. They say that some patterns and characteristics of problems that we humans face, share the patterns of the problems that are solved by computers. So we all have to operate in spaces where the amount of time and information we have is limited. So how do you make the best decision in such environments based on the limited resources we have? That's not unique to computers, and that's not unique to humans.
Yes, there is a certain overlap between computers and humans in the way we make decisions. And this book, Algorithms to Live By, is all about that. So this is how we are going to do it. We are going to talk about 2 chapters of this book in detail, and the very first chapter that Merl wanted to select was chapter number 1, which is called Optimal Stopping, When to Stop. So just to give you a background about what this particular problem of optimal stopping is, we will use the very example that is used by the authors in the book.
So assume you arrive at a new city for your employment or for your education, and you don't have all the time in the world to find a good apartment or a boarding place, but you have some amount of time. So how do you go about solving this problem? How do you find the best apartment for yourself? So one thing to do would be you list all the free or ones that are up for rent or for purchase, and you go and check the first one. And if you like it, maybe you commit to it. Yeah. But the problem there is that might not be the best apartment. That might not have the best facilities, and that might be a bit too expensive even though the facilities are good. But you can't also wait till the end, because on one hand, if you let go of one apartment, there are others like who are facing the same problem and who might come and grab that opportunity. But you can't like also wait till the end, because you won't be left with an apartment because everything else is taken. So what's the optimal point where you stop looking? Intuitively you might see the path to the solution where you should look for some time and when you find the best one, you should commit to it. That's the general intuition, which is actually correct. But the precise solution or the optimal solution is going to be you have to decide like how many apartments that you are going to look, or how much time you are going to spend, and depending on the number of apartments, you look for 37% of the all apartments, and you just randomly explore them. You don't commit to them, but you get a sense of what the quality was. But after that particular point, after 30% of time, or after 30% of the apartments you've looked, then the next best apartment, or the apartment which is better than the previous 37%, you immediately commit to it. And that has been proven to be the algorithmically optimal solution to this problem.
Say you have 10 days to find a boarding place when you move to a new city. So you take 37% of that 10 days, which is, let's say, 3.5 days. You spend 3.5 days looking at apartments with absolutely no intention of committing to any one of them. You're just looking at them and evaluating. So after this 37%, what you should do is, when you see at the very first time, when you see an apartment which is better than everything you saw in the very first 37%, you should immediately commit to it.
That's right.
Yeah.
So for the more mathematically inclined, the people who actually want to know what this 37% is and are curious about this is actually an approximation of 1 over E. E is the natural logarithm. So that's the solution. I mean, when you solve the problem of optimal stopping, you get an approximation which is roughly 1 over E. So that's where the 37% comes from. And you all can like look up on the internet and like try to do the proof yourself. But if we apply to our like previous example of finding your partner in life inside the university. So take your 8 semesters, and 37% might roughly be like about 3 semesters. So during your first 3 semesters, you won't commit to a boyfriend or a girlfriend, but you keep looking, you keep your options open. But after the third semester, when you find someone who is better than everyone else you've come across in your first 3 semesters, and that's going to be the love of your life.
Yeah. That is a mathematically proven love of your life. So that's guaranteed to be good.
I mean, now there are like all sorts of caveats. That's the beauty of the whole thing, and which we might get into later. I mean, it's not like when you have a reputation of like dating all the girls in the university, it's unlikely that people who are going to come later is going to like you, but that's a separate discussion.
Say you spend first 3 semesters just, talking with girls or talking with boys with absolutely no intention of committing to any one of them. And after the 4th or 5th or 6th semester, you meet someone who is better than the people that you met in the first 3 semesters, and then you ask him or her out. What if they say no?
Yes, I mean, this is a very likely scenario, which means you are going to get rejected more often. But there is a solution for this, and it has been, people have calculated this before, and the answer turns out to be 25%. Again, it's an odd number, but the idea is if you get rejected more often, you need to commit early, because your chances of finding the optimal person at a later stage are slim. So your commitment point begins much earlier at 25%.
Yeah, you can actually do the math and see if you are really interested in it. If you have a 50% chance of getting rejected, like by the person you are hoping to commit to, then your optimal stopping point shifts to 25%. If
that's right.
Yeah, if your chance of getting rejection is even higher, let's say 75% or 90%, it might come even below, like 10%, or say you have to only look for people in the very first semester, and then after that you have to commit to the very first person you meet who is better than.
Yeah, it all depends on your personal traits and how good you look, and it becomes like a probabilistic function of your likelihood. And so that's the beauty of it. I mean, it's not the same for everyone, but so the 25% is like you rightly pointed out, is if you have a 50% chance of someone saying yes.
Then there is an interesting variation like this. Say, you talk with a few girls in your first 3 semesters, and then you talk with a few more girls in the 4th, 5th, 6th, and so on semesters. But then you really think the one for you is someone that you met in the very first 3 semesters. What if you can go back to them and then ask them out, and there is a chance that they will say yes?
Yes, so in a university setting, I don't know how likely this is going to, how high realistic this is going to be. But if you have the chance of going back and you know that they will say yes, the optimal algorithm suggests that you should wait till the 61%, or like the, I mean, if you divide the time, you should, during the first 61% of the time, you should not commit. It's only after that you should be committing.
Yes. So if you think the girls that you talk with in the very few semesters of your university life is like going to say yes, even if you come back to them after dating, I don't know, talking with a dozen other girls, if they're still going to say yes, then yes, you can go ahead, not commit to anyone in your first 6 semesters, and then look for some people in the 7th and 8th. If you still don't find anyone good, you can always go back to someone that you met in the first 6 semesters and still ask out.
I mean, there's an example in the book of where this actually happened. Yes. About, I think, was it Galileo Galilei? Yes, I think
it was Johannes Kepler. Yeah.
Okay, Johannes Kepler, yeah. So what happened was, so he went about to find the perfect life partner, and he, I think, like explored his options, and he really liked the third person that he met, but he didn't commit to her. Yeah. But after about his 11th interaction with a potential life partner, he realized that all the time he really liked the third girl, and he went back to her and he proposed to her, and luckily this yes. person obliged, and they lived happily ever after.
Yes. So these are the 2 variations that we want to talk about, which is called the rejection and recall in this particular optimal stopping problem. And that there are other scenarios where this optimal stopping, this principle of optimal stopping can be applied to your life. Like finding a partner is one of them. Have you ever come across a chance where you can apply this personally at a problem that you have faced?
I mean, yes. I mean, I directly applied what was in the book in the real life. So, not that I calculated like precisely what the 37% was, but the idea is that, say, you are in a busy parking lot or a busy area, and you really need to find the optimal parking spot. You don't want to park your car 2 kilometers away and walk, but you don't also want to like go really close to the place you want to go and not find parking. Like, how do you find the optimal position to optimal place to find a free parking spot? I mean, there is a solution. So it depends on obviously the occupancy rate. If you have a sense of what's the occupancy rate of the available parking, depending on, so if it's 60% free, then you should stop at a particular distance and commit to the next free parking spot you should find. So obviously, depending on the occupancy rate, the position that you should commit to the free parking spot varies. But this is something I mean, at least as a heuristic, keep in my mind. So this appears to be too close, or this appears to be too far. And depending on that trade-off, I usually find the parking spot. Again, I mean, I don't do the calculations like I said, but this is a useful heuristic to carry in your head.
Mm-hmm. Yeah, actually the authors have given a table of numbers where you can actually use this. If every parking spot has a chance of 50% of being occupied by someone, then you should go close to the place that you want to go, and you can try and find one parking block within that particular place. But if you really interesting these numbers are, but if there's a occupancy rate of 99%, which means it's 99% sure that any particular parking spot being occupied, then you should try and take the first parking spot 69 blocks away from the place that you want to go. So yeah, it's these numbers are really interesting. And if the occupancy rate if it goes even above 99%, just don't drive at all. You won't find a parking spot. Just, I don't know, take the bus or walk.
That's right, yes.
Yeah. So, Algorithms to Live By, for me, was a very insightful book. And whenever I read a good book, I have this habit of looking up the authors to see what kind of people these people are, what kind of knowledge they have to make these claims. So yes, I did the same thing. I went ahead and looked up Brian Christian, who is one of the co-authors. So he turned out to be an American non-fiction author. He's also a poet, a programmer, and a researcher. He was born in 1984, and he has a degree in computer science, philosophy. He also has an MFA in poetry. And he has also authored another best-selling book, which is called The Most Human Human, which was published in 2011. So if you like Algorithms to Live By, maybe you can go ahead and read The Most Human Human as well.
Yeah, so the other author of the co-author of the book is Tom Griffiths. He's a professor of psychology and cognitive science, and his interests include developing mathematical models and understanding formal principles that underline our ability to solve problems faced in everyday life. So he has a background in psychology and in statistics. So I think this is a very interesting combination. People who are well versed both in decision making, psychology, and like statistical modeling, it makes for a really interesting read.
Yeah,
and
this the full package.
The book, by the way, was like really popular and it won several awards. So it was one of the best science book of 2016 according to Amazon, and the MIT Technology Review listed as one of the best books of 2016, and it like went on to win a lot of awards like when it came out in 2016.
Yes, so we would recommend you read the book. Just decide for yourself if it's actually worth all these awards. You're listening to RadioPublic, the podcast about great books and smart people. Our guest today is Mr. Merl Chandana, past president of the Gavo Club of University of Moratuwa and researcher of data, algorithms and policy team at LIRNEasia. We are talking about algorithms to live by. For me, there was one other chapter in this particular book which struck a chord with me really well. This is something that I hadn't given a thought of at all, ever in my life. It's called Computational Kindness. So it might sound a little bit corny, but hear us out. This is what it's about.
So computational kindness, I'll try to put in very simple terms. So it's about, the idea is if the brain has very little to do, it is more likely to do it. So the idea is you want to create situations where the brain doesn't have to think too much. And if you are doing that, you are being computationally kind. And this applies really in situations where people are overloaded with information and you need quick decisions made.
Yes.
So if I am to take an example, so say if you are setting up a meeting with a group of people, rather than openly asking everyone, suggest a possible time, a better option would be to give them a couple of options from which they can choose. I mean, if you let everyone come up with options, they'll have to think through and assess everybody's schedules, and they'll have to go through a lot before making the decision, and they are likely to postpone it or not make the decision at all.
Yes. If I'm a member in your team, then I would definitely I would definitely like to choose between two time slots that you give, rather than going through my entire calendar and then looking for possibly free slots for everyone. So,
I mean,
yes.
this is something I've actually implemented in my real life, and I do it on a daily basis. I mean, sometimes we are hesitant to do this if we want to set up a meeting with someone more higher up. So if we think we want to set up a meeting with our boss or a superior, we tend to hesitate before suggesting
Yes.
them times, because we think they are in the position of power and they should be determining what the optimal time is. But what I've realized is that even for them, and perhaps especially for them, because they are busy and they don't have time to think about these things, they are often more happy and even more grateful if you give them a couple of options. Now, if they can't commit to any of the times, of course they'll say no. Then either they'll say a potential time, or you can suggest another time. But if you want a decision made quickly, and if you want people to commit to things, you should probably make it computationally kind.
Yes. Another scenario where this could be applied is, okay, imagine. So you're with a set of friends. Even better, you're with your girlfriend or boyfriend or wife or husband. So you want to go out and have dinner. So one person asks the other, okay, let's go out for dinner. Where do you want to go? And the second person replies, I don't really have a preference. Why don't you choose for yourself? There are 3 fundamental problems about this particular scenario. Problem number 1, I would say, is one person is forcing the other party to compute too many possibilities. So you ask from your partner, where do you want to go and have dinner? The second person should think of all the possible places that we can go, and then weighing all the pros and cons to each and every one of these restaurants, and then pick. So this is something very computationally intensive. Just like we talk about in computers, it is computationally intensive, but this is often done with good intentions. Just like Merl said, you think you are doing something very polite by asking the partner to choose the restaurant, but then it might not be the case.
I observe a similar scenario on the various WhatsApp groups that I am on. So say if a group of friends want to meet up, and someone at one point asks should we meet? When should we meet and where should we meet? So it takes a while and nobody has an answer. So what I've observed is so these are the 3 possible dates that we are proposing, and these are the potential places that we might want to go to. Make a pick based on the majority's preference. We'll make the call and we'll actually meet up. And if you want to get things done, rather than throwing open-ended questions, it's always better to constrain and have some decisions, some boundaries already set up, having done some of the computation, so that the people making the decisions will have an easier time.
Another situation that might come up when you are making group plans like this is one person or a set of people would just say, I don't really have a preference, so I'm free all the time, or I'll be flexible. Now, for these people also, they might think that they are making the decision easier for everyone. But it's not actually the case, where if you say you don't have a preference, what you're really doing is you are pushing that entire computational load at someone. When you are not really weighing in to the decision-making process, someone else would have to take that computational load and make the decision for you. And if you are making dinner plans with your partner, and you say that you don't have preference, the other person kind of has an obligation to simulate the decision-making process of you. And then in addition to thinking what restaurant would be the best, he or she has to actually think whether you would like this option. So simulating someone else's thinking or someone else's decision-making process is one of the hardest things out there, computationally speaking.
And something else you want to understand in these matters is, in these kind of scenarios, there's no one perfect solutions.
Yes.
There are better solutions, there are comparatively worse solutions. So picking among fairly better solutions should be your goal, and the perfection should really not be the enemy of the good.
Yes. So unless you are computationally kind to each other during this particular decision-making process, there's a high chance that all of you will be overwhelmed by trying to decide, or all of you might agree to a solution that none of you would like.
That's right. Yes. And I mean, one more thing, like something that I picked up, like when you were speaking, was that like when someone says like you are completely free, I mean, nobody ever is really completely free.
Yes.
I mean, people have commitments, and the other person, I mean, might think like even though he says free, obviously he has things going on in his life. He can't be a monk living 24/7 meditating.
Yeah.
So that's not the case.
And this is something that just came to my mind. It wasn't in the book, but it's something that I read somewhere else. I would like to call this particular concept being computationally kind to yourself. So I read this particular habit of the very famous physicist Richard Feynman, where Richard Feynman, whenever he goes to the ice cream shop to have ice cream, he wouldn't even look at the cabinet. He wouldn't even look at the menu. What he would do is he would just go to the shopkeeper and ask for a chocolate ice cream. And one day, a colleague asks about this particular trait, and his answer was like this. So he's a physicist. He has so many things to think about. He has so many difficult decisions, difficult computations that he should carry out in his mind. And selecting a flavor of ice cream out of 10 different flavors is not something that he would computationally load his brain with. Yes. This particular concept is called decision fatigue, where you make too many decisions, you fatigue yourself. And if you try to be computationally kind to yourself, maybe you can skip a few trivial decisions, day-to-day decisions, and then automate them, maybe. Maybe the next time you go to ice cream shop, don't just because ice cream, different flavors of ice cream, that's a very hard decision to make, right?
I mean, so this idea actually of, I mean, we are going on a tangent, but I think it's an interesting tangent. This idea of decision fatigue is what actually lies at the heart of this emerging field called behavioral science or behavioral economics. So one of the best success stories of behavioral economics happened in the UK. So what happened in the UK was, so they had a public sector pension scheme, so where they had given people a range of options, about 25 to 30 options to pick from, and they could they had to do all the calculations and get themselves enrolled in this pension scheme. But after they deployed it, what they realized was that nearly 60% of people, I might be getting the number wrong, but definitely more than half of the people who tended to benefit from these pension schemes had actually not enrolled themselves. So they proposed this idea of, let's do this, like let's make a reasonable hypothesis and automatically enroll everyone into the pension scheme while giving everyone the option to switch to something else if they wanted to do it. So once they did that, they were able to increase the enrollment rate into the 90s. So if you give people the option to choose between a complex array of options, they are more likely to defer it, they are more likely to postpone it, or not do it at all. So removing the decision fatigue and having some sort of a good solution, perhaps, arguably is always or almost always better than the optimal solution.
Yes. So computational kindness is all about making decision making easy for the people around you or even for yourself. So be kind to your computational capabilities, which is your brain. So yes, that's about computational kindness. So these are just a few of the concepts that Brian Christian and Tom Griffiths are talking about in this particular book, Algorithms to Live By. So Merl, do you have any closing remarks?
I think that the take-home message from all of this, and really from the book, is that even computers aren't these perfect machines of infinite capacity and resources where they always make the most rational, theoretically ideal decisions without ever failing. So they make random guesses, they use heuristics, they try to optimize the resources in the best possible manner. And like I happened to mention previously, they don't make perfect the enemy of the good. So they try to make the best of the available resources and the circumstances. I mean, in our lives, we tend to procrastinate a lot because our task at hand seem to be very, very difficult, and we don't we want to have the perfect plan before we even begin. But what computers do is they make certain assumptions and they break the problem down into parts, and they try to define each step as precisely as possible, and they arrange these tiny steps one after the other to get a job done. So I think this is an ideal way of solving difficult problems.
Yes, exactly. So despite the general belief, humans and computers have too many overlaps than we can usually imagine. So applying a certain algorithm or a certain concept in computer science to your life is not as far-fetched as you might think at first. Go ahead and give this book a read.
And find out whether there are algorithms that you can live by.
That's about algorithms to live by. And thank you, Merl, for coming on my show. I think it was a really good experience for our listeners and definitely for me. Thank you very much for being on my show.
Thank you for having me, and hope we'll meet in a later date with another book.
Yes, with another book.